Hello, welcome to the session on straight cutting on ferrous and non-ferrous metal using plasma arc cutting (PAC). Let us look at the objectives of this session. At the end of this session, you will be able to mark cutting lines on the plate by keeping proper cutting allowance, set the job for straight cutting, clean the edges and inspect for defects. The tools and materials required to straight cut on ferrous and non-ferrous are plasma cutter, welding helmet, welding gloves, welding apron, torch tip, electrode, shield cup, bench vise, wire brush, chipping hammer, hand grinder, drag shield. First, let's understand the safety procedures involved while using a plasma cutter. Be aware of potential hazards involved with the process, including high voltage, noise, temperature, flammable materials, fumes, ultraviolet radiation, and molten metal. Elevated temperatures cause burns, and flammable materials may ignite. Harmful fumes can be inhaled, and ultraviolet radiation can damage skin and eyes. Molten metal carries burn hazards. Proper welding clothing should be worn, as well as shaded eye protection, as specified by the manufacturer. As with all industrial products, read the owner's manual for proper safety procedures. Now, let's understand the pre-cut checklist before using plasma cutter. Inspect and replace worn torch tip, electrode, and shield cup to avoid poor cutting performance and operator frustration. Check gas or air pressure at the compressor or bottle gauge. Turn on the plasma cutter. Set the amperage control to the maximum setting. The air pressure should be within the range specified in the plasma cutter manual. If the air pressure is not within the specified range, adjust the air pressure regulator. It is important to grind off any rust or paint where you plan to secure the ground clamp. This is because the plasma cutter creates a high voltage arc that can be easily conducted through rust or paint. This step is especially critical with 12 amp machines. These machines do not have the power to drive through rust and paint like larger units do. If the ground clamp is not properly grounded, the arc can even damage the metal, causing the machine to overheat or even damaging the torch tip. Use a wire brush or a grinder to grind off the rust or paint. The ground clamp is used to complete the electrical circuit for the plasma cutter. It should be placed as close to the cut as possible to minimize the voltage drop and ensure a good electrical connection. The clamp should also be placed on the workpiece itself, rather than on a table or other object, to further minimize the voltage drop. When using a plasma cutter, it is important to relax your grip on the torch. If you hold the torch too firmly, your hand will shake more, which can make it difficult to make a clean cut. Now, let's learn the plasma cutting procedures on ferrous metal. The first step is to place the drag shield on the edge of the base metal. The drag shield is a metal plate that helps to protect the torch tip from the heat and sparks of the plasma arc. It is placed on the edge of the base metal or held at the correct standoff distance, which is typically 1/8 inch. The arc should be directed straight down, not at an angle. Dragging the tip of the torch across the metal will damage it. Make sure to keep a proper standoff distance. If the standoff distance is too close, the torch tip will overheat and damage. If the standoff distance is too far, the plasma arc will not be able to penetrate the metal. The second step is to raise the trigger lock. Press the trigger and the pilot arc starts immediately. The trigger lock is a safety feature that prevents the torch from accidentally firing. To start the plasma arc, raise the trigger lock and press the trigger. The pilot arc will start immediately. The pilot arc is a small, low amperage arc that is used to ignite the main cutting arc. Once the cutting arc starts, begin to slowly move the torch across the metal. The speed of the torch should be adjusted so that the sparks from the arc go through the metal, exiting at the bottom of the cut. If the sparks are not visible at the bottom of the plate, the arc is not penetrating the metal. This can be caused by moving the torch too quickly, insufficient amperage, or directing the plasma stream at an angle, but not straight down. Insignificant grounding can also cause this problem. The higher the amperage, the hotter the plasma arc and the faster the cut will be. However, too much amperage can damage the torch tip. The gas helps to cool the torch tip and prevent it from overheating. It also helps to shape the plasma arc and improve the quality of the cut. At the end of a cut, angle the torch slightly towards the final edge or pause briefly before releasing trigger to completely sever the metal. This will help to prevent the metal from being dragged along by the torch. To cool torch, post-flow air continues for 20 to 30 seconds after releasing the trigger. Pressing the trigger during post-flow instantly restart the arc. The post-flow air helps to cool the torch and prevent it from overheating. Pressing the trigger during the post-flow will instantly restart the arc. The same procedure is applicable for cutting non-ferrous metal. Let's recap the key points discussed. Understand the safety procedures involved while using a plasma cutter. Pre-cut checklist before using plasma cutter. Procedure to cut ferrous and non-ferrous metals using plasma cutter. This brings us to the end of the session. Hope you have gained a good understanding about the straight cutting on ferrous and non-ferrous metals using plasma arc cutting, PAC. See you in the next session.